Okay, so welcome. We're going over ACT Worksheet 202 Algebra. Algebra is an essential part of the math section of the ACT. There are ways to figure out problems if you're uncertain in certain areas with your algebra, but for the most part, you really, even with the calculator, you really need to be solid on the four things I have in front of you. So solving and isolating a variable, how to use substitution and elimination as it pertains to systems of equations, being able to write equations out when you have word problems and then solve for variables, and then just understanding how to factor quadratics and how to use a quadratic formula if it's not easily factorable. Uh, so we'll go through all of that and then we'll do some problems from the test. What I'll say is this, that the first half of this video is kind of going through the essentials or the basics of algebra. If you feel pretty good with that, skip to the second half of the video, because the second half, when we're going over problems on the worksheet from previous tests, I've picked some of the more challenging problems. If you're a little bit tentative with algebra, watch the first half of the video and watch the second half, but don't be intimidated if some of the problems on the second half feel a bit difficult. I picked ones that come from kind of, for the most part, from the back 20. So problems 41 to 60, which tend to be the harder one, which are the harder ones on the ACT. Anyway, let's just get right into it. So the first thing we'll look at how to do is just how to isolate a variable. And those who have trouble with isolating a variable, the best piece of advice I can give you is it's just the reverse and the inverse of doing order of operations. So BIDMAS, brackets, indices, division, multiplication, addition, subtraction. If I were to put in a 5 for this x, we would make sure we did the steps in exactly that order. So first we would add the 3 to the 5 within the brackets. Then after that, we would do the indices. So we would do the squared, and then finally we would divide by 4. So when you do BIDMAS, you go in that exact order, right? You add the 3, square that to 64. So you take the 8, you square it to 64. Then last but not least, you divide by 4, and that gets you 8. Or not 8, I'm sorry, that's terrible. It does not get you 8, that gets you 16. So anyway, the easiest way to isolate a variable is say everything I do when I do BIDMAS, I just do it exactly in reverse. I'll show you what I mean by that. So pretend we had the same exact problem, except now it equals 16. And as you can see, I want to kind of have all parts of the screen so you see it down here. So all these steps that we just did, we're just going to do the opposite of them, and we're going to do it in reverse. So if we're trying to isolate x, instead of dividing by 4, what we're going to do instead is we're going to multiply by 4 to try to move things away from the x. So our first step, instead of dividing by 4, is going to be, I'll just do that for multiply by 4. So we're going to multiply by 4. Okay, so that's going to get us x plus 3 squared equals 64. Then the second thing we're going to do is, instead of squaring the quantity, right, we're going in reverse. We're trying to isolate x. We're going the reverse of BIDMAS. So instead of doing what's in the brackets, we're going to try to get to the brackets. So we'll take the square root of both sides. So I'll just do this for square root both sides. So that's going to get us x plus 3 equals 8. And then last but not least, then we'll do what's in the brackets. We'll subtract the 3, right? So instead of adding the 3, we'll subtract the 3. So let's do that for subtract 3. So then we get x equals 5. So if that's something you've always had trouble with, isolating a variable, not knowing kind of which steps to do in which order, it's literally the reverse and the inverse of BIDMAS. So this is explained further kind of here in this packet, and you also have some practice problems to try out right here and the steps explained. So if that's something you don't feel good with, something you definitely want to have down for the test. It's just kind of essential algebra skills. You can get the practice right there. Okay, The other thing you need to be very comfortable with is being able to solve a system of equations, specifically knowing how to use substitution and elimination. So most students feel pretty comfortable with both of these, so I'm going to go through these pretty quickly. So if we're going to do this with substitution, let's say we're going to solve for x, we would just say on the bottom, we would say, okay, y equals 9 minus x. Now that I've isolated the y, I can sub in for the y. So we have 2x plus 3 times 9 minus x, I'm just subbing in what I know y to be, equals 25. Okay? From there, we have 2x plus 27 minus 3x equals 25. So really what we're looking at here is negative x equals, when we subtract the 27 from the 25, negative 2, so x equals 2. And if we needed to figure out y, we could just plug the 2 back into either one of these equations. If we plugged it into this one, we'd realize pretty quickly that y is going to equal 7. Anyway, the other way to do this is to use elimination. So if we wanted to use elimination, and again, if we're going to solve for x, let's say, we'll multiply the entire bottom by 3. So what we'll have on the top is 2x plus 3y equals 25. And on the bottom, we'll have 3x plus 3y equals 27. And now if we subtract, and the reason why we multiplied by 3 was now we have 3y and 3y. So if we subtract one equation from the other, we're going to completely eliminate that 3y. So what we're going to end up with is negative x equals negative 2. So x is going to equal 2. Okay, so that's how to do the substitution and the elimination. So then, and we'll do that with a word problem in the middle, but in a minute. But here's what you may see on the test is you may see kind of almost a long paragraph, and you have to put the pieces together for an algebra word problem. So let's look at this example. So we have Sandeep stars in a one-man, by the way, pardon my humor or sense of humor. If you don't think it's funny, then that's okay. Most people probably don't. But anyway, I tried to write this word problem with a little bit of flair. But anyway, Sandeep stars in a one-man performance in the garage of his house, which he has repurposed as a theater. He insists that his 3-hour monologue will make audiences laugh and cry with an upswell of powerful emotions. It costs Sandeep $6,522 to transform his garage, and he's also going to lose $4,200.58 in pay for taking the month off from his job. Sandeep plans to charge 22 for standard adult tickets, represented by X, and 15 for senior citizen tickets. Sandeep has sold 120 senior citizen tickets, which is all that he is allotted for the show's run. Which of the following equations represents the number of standard adult tickets Sandeep must sell in order to completely offset his costs and monthly wages? Okay, tons going on there. But understand that what the problem wants from you is something in terms of price, because we need to offset how much he's paying. So how much is he paying? Well, he's paying $6,522 plus $4,258. So that's how much he's in the hole. So we need to offset that. So if we add these together, we get $10,722.58. Okay. So we need to figure out how many standard adult tickets he needs to sell in order to cover this cost. But we know that he has already sold 120 senior citizen tickets, and that's all he plans to sell for senior citizen. So what we have is we need everything in terms of price. So we'll take the number of senior citizen tickets, but we have to multiply it by the cost per ticket to turn that number of 120 into a price, right? If we have 3 tickets, we would multiply the 3 tickets by $15 in order to figure out how much all 3 tickets cost together. So we're just changing the number of tickets into a price. But then the other thing we know is that he's going to, at $22, he's going to sell his adult tickets a piece. So really, this would be our equation, right? We have the total amount of money he needs to make up. We have how much money in total he's going to get from his senior citizen tickets. And then right here, we have the dollars he gets per ticket, and then this is the number of tickets. So we would just need to know how to isolate X, which is something we worked on above. Okay, let's look at this second equation, or this second word problem. Okay, so I apologize if it's a little bit small here. So Sandeep is at it again. With a resounding success of his critically acclaimed one-man tour de force, he has decided to produce a musical about the United States founding father Thomas Jefferson, which he plans to title Jefferson. Assume that Sandeep sells out his 2,500-seat venue every night, because he will, and that his nightly revenue is always the same for both types of tickets. If standard adult tickets cost $35 and senior citizen tickets cost $15, how many senior citizen tickets does Sandeep sell on a nightly basis? Okay, so we need to figure out how many senior citizen tickets Sandeep is going to sell on a nightly basis. Okay, so we're going to need two equations here. One equation is going to be for the number of seats, and so that will be our number equation, number of seats. And then the other equation is going to have to deal with price. And that's fairly standard. You usually have one for just straight out amount, and a second equation is a system of equations for like price or points. So anyway, if we're looking at this, what we know is we know that his standard adult tickets plus his senior citizen tickets has to equal 2,500. And if we're looking at price, what we know for price is, well, one, we know that it's $35 for a standard adult ticket. And we also know that it's $15 for a senior citizen ticket. But the big thing we know is that his revenue is always the same for both tickets. On a nightly basis, his revenue, meaning money, and this is our money equation right here. So I should probably put a money sign next to this. The amount of money he makes off of both is always the same. So that means that the amount he makes off of the standard tickets, 35 times the number of adult tickets, is the same as 15 times the number of senior citizen tickets. So now what we're looking at is we just have a system of equations here, and we have to decide whether we want to use substitution or elimination to solve it. In this case, I think substitution is probably going to be easier. So let's figure out the number of senior citizen tickets Sandeep must sell. So in order to figure that out, what we're going to do is we're going to say that A equals 2,500 minus S. Now we can sub in for the A and eventually isolate S. So 35, 2,500 minus S equals 15S. I'm going to use my calculator. 35 times 2,500. And that's going to be 87,500. If you did that in your head, kudos. I am on video, so I didn't want to mess that up. Minus 35S equals 15S. So essentially what we get here is 87500 equals 50S. And if we divide that number by 50, we get 1,750. So that is the number of standard tickets. And if you weren't sure if that was the right number, you could kind of plug it in back into the equation. If you know this is 1,750, then you know that the adult tickets would have to be 750 to equal 2,500, and then you could plug those two numbers in and see if that balances out. Anyway, one last concept, and then we'll get into the problems from the worksheet. Okay. So the last concept is you just need to know quadratic formula. Won't always come up on the test, but I'd say maybe once a test, once every other test, it kind of does come up. And it's essentially if you have a quadratic, meaning x squared is your highest power, if you need to be able to solve for your x-intercepts, in other words, when this equation equals 0, so when 2x squared minus 10x minus 6 equals 0, if you can't factor it, it's helpful to know that you have the quadratic formula. So you're putting the 10 there, it's negative 10, so you make it 10. Your a is 2, so 2a, that just becomes 2 times 2. Anyway, I know you guys know the rest. I'm not going to get into details, but if you don't have the quadratic formula memorized or you don't really know when or how to use it, understand that it's to solve for your x-intercepts. In other words, when your output for y is 0, when you have a quadratic. Anyway, let's look at a few problems from past tests. Okay, so I'll do 8 pretty quickly. There's 2 ways to do 8. And as always, feel free to pause the video and give it a shot yourself. Or if you just want to see how to do it, you can just kind of keep it rolling. Anyway, the fastest way is to realize that the top is x minus 7, x minus 7. The bottom is conveniently a difference of squares. We can get that by x plus 7, x minus 7. Right? That's the concept that if you have x minus y times x plus y, what you end up with there is x squared minus y squared. Right? The middle terms end up canceling out. So that's what you had here. You had a perfect square, x plus, so plus 7 and a minus 7, and then you get an x squared up front. So anyway, what happens here, conveniently, is these cancel out, and our answer is that. Pretend you didn't see that. You're not totally out of luck on this problem. Whenever you need to match expressions, you can always just pick a number for the variable. So the same equations, if you put in the same, or expressions, if you put in the same input, they should yield the same output. So let's just make x equal 9. So I make x equal 9. Watch what happens here. I end up with 9 minus 7, which is 2. 2 squared is 4, so we have 4 on the top. On the bottom, 9 squared is 81. 81 minus 49 is going to be 32. So what we find out is if we input 9 for x, we're going to output 1/8. So we know that if we input 9, we should output 1/8. Well, if we look at this top one right here, if we input 9, we end up with 2 again, right? Or not 2. Yeah, 2 over 16. And that's going to be 1/8. So that's not a coincidence that those match. So that's just a backdoor way. If you're not sure how to go about it, or you don't remember your perfect squares or difference of squares, you can just plug numbers, get an output, and then plug through the equations and look to match. Okay. So this is a really interesting one, 32, and this kind of has to deal with quadratics as well. Again, feel free to pause the video and try it yourself if you'd prefer, but I'm going to keep on rolling. So what this says is it says, consider this equation x squared minus 6x plus k equals 0. When solved for x, this equation has exactly one real solution. Which of the following could be the values of k? Which of the following could be the values of k? Okay. So this is a perfect square, okay? In other words, to have only one solution, this needs to be x minus some number, I'm just going to call it p, squared is going to equal x squared minus 6x plus k. So the question essentially is, how do we get a perfect square? And the way we do it, and I'm just going to kind of give away the answer here, is it's going to be d. It's got to be 9, okay? The reason why it's got to be 9 is if you think about completing the square, if you half this 6 to -3, and then you square it. So if we half the 6 to -3, and if you're not sure how to complete a square, you may want to kind of look that up on the internet. But if you half it and then square it, you'd end up with x squared minus 6x plus 9. We halved it to -3 and we squared it. That completes the square. It makes a perfect square, meaning that this is going to be x minus 3 squared. So that gets us a perfect square. In other words, that gets us only one solution for the problem. If the problem only has one solution for x, k has to be 9, and x would be 3. There is another way to do this one, probably the road less traveled, but I'll show it real fast. Some of you may remember the discriminant from the quadratic formula. So when we have x equals b, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Well, the thing is this, b squared minus 4ac, this part under the radical, that's called the discriminant. What does the discriminant tell us? It tells us how many solutions we have for x, how many x-intercepts we have, how many times we cross the x-axis. So if b squared minus 4ac equals 0, that means that our parabola only has one solution. It's going to be a vertex that just touches. So if you think about this problem, another way we could get it right is we could say, okay, -6 squared minus 4 times 1 times c is k in this case equals 0. And we want to figure out what k is. Well, 36 minus 4k equals 0. Doesn't look like a k. Now it does. Negative 4k equals negative 36. So k would have to equal 9. So that's another way to do it, probably the more official way. Anyway, that's kind of a couple problems dealing with quadratics. As you can see, it can be helpful to know quadratic formula. It's definitely something that comes up every other test, where it's just to get a problem, it's helpful to know it or you'll need to know it. Okay, let's look at, this was kind of the first concept we covered, and here's a harder version of it from a past test problem, but let's look at how to isolate a variable. So feel free to pause the video, but I'm going to keep on going. Each student's project in a history seminar is given a point score by the teacher and by each of the other students in the seminar. A student's project grade is determined by this formula, and we're given this formula, where T is the score the teacher gives, S is the sum of the scores the students give, and N is the number of students in the seminar. What is T in terms of G, S, and N? Okay, so in a nutshell, with all that noise, all it's really asking, but it's good that we read the whole thing carefully, but all it's really asking is, can you isolate T? So if you remember, we are doing BIDMAS in reverse. We're doing the reverse and the inverse of everything we would do if we had plugged in a number for T. So to kind of get T by itself, the first thing we're going to do is we're going to remove the denominator. So we're going to multiply both sides by 3 plus n. So that's going to get rid of the denominator, but we're going to end up with 3 plus n times g equals 3t plus s. Okay, so we end up with 3g plus ng equals 3t plus s. Feels kind of weird because it's just a bunch of variables, but again, all we're doing is just moving things away from t. So the next thing we have to move away from t is we have to get rid of the subtraction because we're going BIDMAS in reverse. So we'll save, or we have to get rid of the addition, and we'll do the inverse of what we would do with BIDMAS. So normally we would add s, but we're going to subtract s. So now what we have is 3g plus ng minus s equals 3t. Now the final thing we'll do is we'll just divide by t. So we have 3g plus ng minus s divided by 3 equals t. And now we're just looking for our match. And that is E right there. Awesome. Okay. So I know this video has been going on a while. You're probably getting a little antsy. So I am going to pick 2 more problems to do, and then that will be that. 45 gives a lot of people difficulty. So let's see exactly how to set up this word problem. So, and again, feel free to pause it. This is one of the last 10 on the test. It says a magnet attracts a nail with a force that varies inversely. So if something's directly proportional, it's y equals kx, whereas x goes up, y goes up, and it may go up by a factor of, let's say, 2. K was 2. So every time x goes up by 1, whatever it is, it gets doubled. So if x were 1, k would be 2. If x is 2, k is 4, and so on. Well, an inverse proportion would be y equals x, y equals k divided by x. Now as x goes up, y is going to go down, right? Because k is a constant. So if k were something like 2, as x gets higher and higher and higher, y is going to get lower and lower and lower. So let's set this one up. So it says a magnet attracts a nail with a force. So the force varies inversely with the square of the distance between them. Okay. So let's look at this. We have k, and it's inverse. So our input, so force is our output, our input is going to be in the denominator, and the square of the distance between them. So that means we're going to take the distance and we're going to square it. Okay. So it says the nail is 12 inches from the magnet. So they're giving us the distance. How many inches from the magnet would the nail need to be to have twice as much attractive force on it as it currently has? Okay, so 2 steps. Let's do the first step. So we need to figure out the current force. So if we think about it, if the nail is 12 inches from the magnet, that means we're putting in 12 for D. So we're going to do 12 squared, and we're going to get 144. So our current force is going to be 144F. And let me see if I missed anything here. No, okay. So actually, let me pause this for a second just to think about this. Stop sharing. Okay, let's resume. Sorry for the pause there. Just didn't want to waste your time thinking aloud, so I paused the video. All right, anyway, if we get right back into this problem, what we have is we know that the force varies inversely, right, with the square of the distance. So the distance squared goes in the denominator. As distance goes up, force goes down. And they give us 12 inches, and that allows us to figure out K. So 144, when we do 12 squared, we get 144 in the denominator. 144F is K. So then the next part we want to know is we want to know how many inches from the magnet would the nail need to be to have twice as much attractive force. So now F becomes 2F. So 2F equals, and we know K is 144F over D squared. So I don't know if you know this trick, but you can easily just switch these two, or if we want to take the steps, we can multiply both sides by D squared. Okay, so that cancels out that. So we have D squared times 2F equals 144F. Take 144F divided by 2F, we get 72. So D squared equals 72. And if we prime out 72, so we have 72 and we're priming it out because we're taking the square root of each side, we would have 2 and 36. And 6 times 6 is 36, so that would get you 6 root 2. Okay. Another way to think about it is when you get to this step, you'd say, okay, we need to have twice as much attractive force when we get to this step. So if we need twice as much attractive force, that means we don't want to divide by 144. We want to divide by half of 144, 72. If we divide by half of what we're dividing by, then our output for F will double. So if you think about it, then you know that d squared, your distance squared, would have to equal 72. And then you just go through the same setup that we had right here of priming out 72. Okay, one final problem that tends to prove very difficult for a lot of people. I will show the easy way first, kind of the logical way, and then we'll look at it algebraically as well. And hopefully what you're seeing is that with these word problems, there are multiple ways to think about them and get them. But anyway, let's look at 53. So Carrie and Manuel are side by side when they begin to run at the same time in the same direction around a track. Carrie runs at a constant rate of 30 seconds per lap, while Manuel runs at a constant rate of 50 seconds per lap. How many seconds after beginning to run will Carrie have run exactly one more lap than Manuel? Okay, I think the easiest way to figure this one out is just to go right for the answer choices and go trial and error. What do I mean by that? Well, let me just show you what this looks like with A. So if we set up a ratio, Carrie runs 30 seconds, takes her 30 seconds to run one lap, seconds, laps. So if she runs for 20 seconds, we can figure out what L is. And for Manuel, it takes Manuel 50 seconds to run one lap. So if Manuel runs for 20 seconds, we can figure out how many laps he's run. And if we do it this way, we can, we're just looking for when L for Carrie is, I'll kind of call Carrie L1 and Manuel L2. We're looking for L for Carrie to be 1 greater than L for Manuel. So here's Carrie, here's Manuel. So if we do it this way, we would have 30 L1 equals 20. And for Manuel, we would have 50 L2 equals 20. And if we think about this, Manuel's going to have run 2/5 of a lap, and Carrie's going to have run 2/3 of a lap. So neither have run over a lap, so Carrie can't have run a lot more than Manuel. She can't have run a lap more. So I'll just kind of speed it up and go right to the answer. C's the answer, and I'll show you why. If we just set this up again, 30 is to 1 lap, as 75 is to L1, how many laps Carrie runs. So 75 equals 30L1. So our L1 is just going to be 75 divided by 30. So we're looking at 2.5. 2 times 30 is 60, and then another 15 to get to 75, so half of 30, so 2.5. Anyway, if we're trying it out for Manuel, and I'll kind of do it right here. So 50 over 1 equals, and then we plugged in, we're just trying out seconds, 75 seconds as the actual time. We're going to figure out how many laps Manuel's run. So 50 L2 is going to equal 75. And 75 divided by 50 is going to get us 1.5. So I think plugging and checking is probably the easiest way to do this one, but I will show it algebraically. So if we look up at this kind of setup we initially put together, it's going to follow the same logic just with variables. All right. I feel like my middle school teacher who'd always like erase the blackboard, but he'd always have stray marks. Okay. Anyway, if we look at this here, we can think of it this way. Carrie is going to run, we'll say, a certain number of laps plus 1, and Manuel is going to have run just a certain number of laps. So that's how we compare how far each one runs, right? They have their same rates that we set up, right? This is Carrie's rate, this is Manuel's rate. But in this case, we know that ultimately Carrie has to be 1 greater than Manuel in the laps. So what we get is we get 30 when we cross multiply, L plus 1, equals 20 for Carrie. And so we have 30L plus 30 equals 20, right? What we end up getting here is, just looking at everything, yep, so what we end up getting here is 30L equals negative 10. Something's wrong there. Shouldn't be getting a negative. Getting a negative because there shouldn't be a 20 there. We don't know how many seconds. Let me actually totally erase that. That was a complete flub up. Apologies for that. So to do this one algebraically, what we're going to do is we're going to say Carrie runs at a rate of 30 seconds for one lap. And she is going to run a certain number of seconds, right? And that's going to get her a certain number of laps plus 1, right? Because she runs one more than Manuel. Manuel is 50 seconds per lap. And we need to figure out how many seconds is it going to take Manuel to run L laps, one less than Carrie. So this gives us a system of equations where we're going to end up with 2 equations and 2 variables. So for Carrie, we're going to end up with 30. So let me erase that. That's a little sloppy. We're going to end up with 30L plus 30 equals S, the number of seconds, what we're trying to figure out here. And for Manuel, we're going to end up with 50L equals S. So now we can easily figure out what seconds is because we have this system of equations. Best way to probably do it is I would probably go with substitution for S, figure out L, and then just kind of backplug. So let's do that. So 30L plus 30 equals 50L. So real fast, what we know is that 30 is equal to 20L. So we know that the number of laps here is going to be 1.5. So L is going to equal 1.5, 30 divided by 20. So if the laps is going to be 1.5, what we want to figure out now is just how many seconds. So real simply, we just take the 1.5, plug it into L right here in the equation we already have, and 50 times 1.5 is going to be 75. So we know that it's 75 seconds is the point where Carrie will have run one more lap than Manuel. Again, I think it's easier to do it the first way I showed you, but the more ways you know how to do it, the better. So whatever feels most comfortable for you. Anyway, I know this video is extremely long. Hopefully you're able to fast forward at points where you needed to. Good luck with Algebra 202.